Hello everyone, thanks for joining my channel Cloud and Coffee with Navneet, and this is the fourth video in this series where we are helping you to learn how you can able to build the Zero ETL AI platform. In the first three videos, I have shown you how you can able to use Zero ETL feature to bring the data from different data sources such as Salesforce, Aurora, MySQL, and DynamoDB and have the data stored into Redshift. Now in this video, I'm going to show you how you can able to go and build the Materialized view. Once you're done with building the Materialized view, then we will be going to go and consume the data from the Materialized view from the different data sources. But I thought like, okay, the Materialized view itself is a very important topic for you to go and understand. So I decided to make a separate video around the Materialized view itself. So let's go and get started with the Materialized view. Even before we go and I can show you the demo around the Materialized view, let's understand the basic. Let's develop the basic understanding around the Materialized view. So think of like, when we talk about the Materialized view, let me zoom in a little so this way it will be better. Okay. So you've been you know the view, the normal view, right? So in a normal view, what you're looking to do is you're going to have a user, you have created a view. In a view, what you'll be looking to do is you will be joining all these three base tables, and then you will be doing a query against this base table. What will happen is every time when you do a query against the base table, this base table runs the query against the data sitting into your main table, right? The table 1, base table 1, base table 2, base table C, base table A, base table B, base table C. So every time when you run a query, you will be getting and extracting the data from these three tables. So what will happen is, in this case, the data will be always will be refreshed. But drawback of this approach is, as the data will be refreshed, but again, every time when you will be running a query, it has to go and execute against this table. So what will happen is, as the table grow, the query becomes slow, right? Because now it will be going and scanning a lot of data. So think of like you've been sitting into library, and every time you're going, how many books are there in the library? You have to go and count the number of books every time, whether there is a change in the library book or whether there's no change in the library at all, right? Whether you have added books, whether you have not added a book, you always have to go and perform the query against. That means you have to go and do all the book counts, right? Whereas in the Materialized view, what will happen is it's create a think of a caching layer. It create a table within the Redshift, or you can call it local table within the Redshift. And what it will do, it store the data. And so if you're joining these three data together, it will be joining the data from this table and have create a Materialized view where all the data is stored. And think of it as a kind of a caching layer on top of this three base table. Why this is important? Because now the data is already pre-computed and is stored into the Materialized view. So every time when user runs the query, do not has to go through and query against all the three tables where it will be doing the join, doing the data shuffling, everything as such. This is the one-time approach where you will be going and storing the data and have the data stored into your Materialized view. Other thing is like, even when the data grows, it has a different options. Like, okay, when you will be looking to do an incremental refresh, it only bringing the incremental data which is being changed across this table and have the data stored into the Materialized view. So this Materialized view has two distinct concepts. One is around what kind of Materialized view you are having. Other is what kind of data refresh strategy you are having around your Materialized view. So when we talk about type of Materialized view within the Redshift, we will be having the standard Materialized view, we are having this auto refresh Materialized view, we are having this incremental Materialized view, And then we are having this nested materialized view, which is more like, okay, materialized view within the materialized view, and then joining with the base table, etc. So like series of materialized view there. And then you're having this auto materialized view. This is a new feature which is announced within the Redshift. What does it mean is like Redshift itself create the materialized view for you based on your query pattern. Other is your data lake materialized view. This data lake materialized view is like, okay, allow you to go and create a materialized view on external table, Apache Iceberg external table, which is there in an S3. And then you will be having the streaming materialized view. Means if the data is coming from the streaming sources such as the Kafka, Kinesis, you can able to go and create the materialized view on top of those sources. Again, as I said, like there are kind of materialized view, and that you will be going to have a data strategy, data freshness around those materialized view. One will be the manual, like based on the schedule. Hey, I wanted my data is not constantly refreshing, and I wanted to go and do a refresh or of this view every day or every few hours, right? This way you will be not, it will not having far more performance impact on your Redshift databases. Other one is you're looking to have an automatic refresh of your materialized view. So as soon as the data base table change, the materialized view will get refreshed. The other will be the incremental. So you will be looking to do and you're looking to do a materialized view where you will be looking to have the data. If the data change, you will be looking to go and incrementally bring those changes within your materialized view. You will be having the cascading, more like in the cascading. This is very interesting. So let's say if you're having the 3 materialized view, like, you know, let me show you. I think this way it will be make more sense. So let's say you will be having your base table, table A, and then you will be having your base table B. You will be having your base table C. So you have created a MB on 1. You have created you have created MB2, and then you have created MB. Maybe just let's have one MB2. So this MB is pointing to this table, this MB is pointing to this table. Now you have created one more MB by joining this two as well. So let's say you will be calling it MB3, and the MB3 is pointing to let's say pointing to your MB1. At the same time, it's pointing to MB2. So you have joined these two MB together, and then you will created MB3. And now you will be having created MB4 with joining this table, and then it will be joining this base table, right? So something of that nature. So something of that nature. So what will happen in the cascading MB is, if you're performing the refresh of MB, let's say 4. So if you're performing the refresh of MB4, the MB3, MB1 and MB2, all 3 of them get refreshed. When you're refreshing the MB3, the only MB1 and MB2 get refreshed. But if you're refreshing only MB1, none of that get refreshed except the MB1. And same goes with the MB2 as well. If you're refreshing MB2, only MB2 get refreshed, none of them get refreshed. So cascading is like the primary node or the leader, the one, if you get if you are kind of, you know, refreshing this one, it has an impact on all 3 of them. Subsequent, like, you know, if you're having the leader, because this leader of this one is this one, so like you can say primary node. If you're refreshing this one, it will be having impact on this one. Here it just kind of, you know, do not have any impact on any of this others. Hopefully you have understood what the cascading is works. And then you will be having that incremental and auto refresh, like, hey, I wanted to do and refresh my materialized view there, and then you will be having that auto. So based on the data freshness strategy you will be choosing, your materialized view will be have impact. So now let me go and show you something interesting as well. And again, I try to create using the GenAI, so it's not that it's not that formatting is not that great, but I think it will serve the purpose. So think of like, this is your graph, which materialized view I should be used. And so it's depend like, okay, how often does your data change? Or if you're already bringing the real-time data. If you're bringing the real-time data, the answer is easy. You can able to have the streaming materialized view, which comes with an auto refresh enabled. It integrates with showing only Kinesis is just an example, but it can be in Kinesis and MSK both. And then you can able to have the real-time data ingested, and that will be the auto refresh. Having said that, like, okay, if you do not have a streaming data sources, like, you can just think of this one. Okay, how the data is changed really. As I told you, like, if the data is changing really, you can able to have the manual refresh around the materialized view, and then you can able to go and control the timing when you're looking to go and update those materialized view. So this will having the less impact on your Redshift. If you're having this frequently, you can able to use, okay, do you need real-time data? So even the data is changing frequently within your base table, do you actually need to have the data move to the materialized view as soon as possible, right? If yes, then you can able to ask more questions. Do you guys have a complex query, such as you could be performing the join or aggregation, or you're just having a simple select statement with a where, right? If this simple statement, you will be able to have the auto refresh, that should work fine. It able to go and provide you, it can able to go and provide you, it can able to go and have your materialized being refreshed in a real time. But if you have the complex query, what kind of use cases you're looking to have, whether you're performing the outer join, if you're having the windowing functions, or if you have the set operator, right? Something of that nature. If yes, you can able to say like, okay, you cannot able to provide the auto refresh, right? That is not that is unsupported feature. You can able to go and perform the incremental materialized view and enable auto refresh, yes, or you can able to only change the data and it will be 10x faster. Okay, other options which is available, okay, is the data can be stale, like, do you need real-time data? No. Can data be stale? Yes. Is the data in a S3 or iceberg format? Yes, that is there if you're able to go and create the data lake materialized view. If not, it's a regular table. Whether it's a hierarchical table or not, it means more like it's using the super type data. If yes, if it's hierarchical, you can able to have the nested materialized view. If not, then it's only having single label. You can also always have this auto refresh materialized view as well. And again, right, it's not covering all the use cases, but I think it's just to give you a good idea when to choose what kind of a materialized view. Other is, I think I have created this one as well. Again, there are different types of materialized view available. I think I have already walked you through. So this is also a good resource. How other all kind of a refresh mechanism is there. So the more important part is what I was telling you earlier is it has to depend on two kind of a factor. One is what kind of a materialized view you are choosing. Other is what will be your data strategy follow. There are a couple of best practices when you will be looking to go and work around the materialized view. Of course, you will be looking to go and removing the materialized view which is not in use, because eventually it will be storing the data in a for you. So you're looking to ensure, like, you are not end up creating a lot of materialized view which you are not using at all. You will be monitoring the refresh performance and the task and see, like, okay, how the refresh is working. So this way you can able to go and change this from the auto to incremental, etc., based on the performance. You will be looking to have a better distribution key and everything as such, because if you're kind of building a complex materialized view where you will be looking to join the multiple tables together, this is again the performance is rely on how your underlying table is being structured. Again, if you will be looking to use the select, you're building it, put a predicate push down, so this way you will be not end up scanning a lot of data, right? So these are the few best practices around you to go and work with a materialized view. Now let's go and see how that look like in a real life. So you can able to have let me go and refresh this one. Let me refresh, then that's refresh itself. Okay, so again, other thing, like in last few videos I've been showing how you can able to go bring the data using the zero ETL from the DynamoDB, from the Salesforce, and then from the Aurora MySQL. So just keep that in mind. All these three tables, or all these three databases actually are read-only databases, because it's using the zero ETL. So you're not able to go and create the materialized view on top of the read-only databases. So you have to use the databases such as a dev or any other databases where you can able to go and create your materialized view. And that's what I did here as well. So now I am having this base table think of, and then I'm going to have this multiple materialized view is created, and this materialized view is few of them are the materialized view and few of them are the simple view. So here think of like let me show you a simple materialized view. So this is your materialized view is created, and then it's a manual refresh. So or if I can able to have auto refresh off on, that can be able to go and help me to go create the auto refresh, but this is again not needed, so it's a manual refresh. So you can able to go and run this query, or you can able to use select query, and when you will be using the materialized view, it will be going and pointing to the materialized view. So for example, let's say select star. Okay, let me run this query here. I got the answer, right? So let me show you, explain. Here it will be going and scanning this materialized view. Okay, now I will be go and select star. So let me, instead of me doing select the star, let me go and run this query. So here, okay, let me, in fact, instead of me showing this one, let me show and run this query here. Select view. Again, this is a normal view. Let me run the query first. Okay, I think maybe let me forget, like let me go and create a view first. Create view, call it this one, and then end up creating a view. Okay, let me just put this schema binding. So here, let me create this view. Now the views got created. Let me go and run the query. So I got this output here. Let me go and explain, and I will be going and running the explain. And if you see here what's going on, it's pointing to the base table. Okay, so this is my base table, DynamoDB public and product review. Whereas when I going and running this one, it's pointing to the materialized view. So hopefully you got an idea how the base table and the materialized view works. Also, let me show you some complex. This one, this is where I'm having the materialized view created. Its materialized view will be joining multiple data together, and we will be going to have it. So what will happen here is and again, one important thing, now we are going and learning about the inner working of this one. So if you see here, every time when I'm creating a materialized view, I see there is a store procedure got created corresponding to each materialized view. So remember I told you, right, it has a two component. One is your materialized view, type of materialized view. Other is you will be refresh strategy. So this store procedure eventually talk about your refresh strategy. So when I had this materialized view here, which I have created, right, which kind of joining the multiple data together and then bringing the data. And when I go and created, when I go and extracted that the store procedure, this is how the store procedure looked like for this one. Okay, so it has a two part. One is okay, let me go and explain this one, because this is very important for you to go and explain, understand. So what the auto generated what's the use of this auto generated store procedure? So it do couple of things. One is definitely will tell you how the refresh look like, whether you're looking to do a full or incremental refresh for your MV. It also ensures there is a zero downtime around the table swapping, so your query should not fail when there are maintenance going on within the materialized view. And then if you're able to have the cascade refresh, right? Remember I told you about how the cascading work. It should be able to go and work with those as well. And then of course you're able to do and maintain the transactions. So this way your data will remain consistent even if there are there are maintenance going on within your materialized view. When I say maintenance, it's more like this, if there are any refresh going on within your materialized view. So the first section is it create this procedures, right? Other section, it will be a decision point, whether you're looking to so even before going there to the section one, let me explain what the section one is talking about. So when it will be creating this MB section overview, whatever this store procedure name is, it has a various field. So this is a start exit, which start talking about the start transaction ID for the delta detections, right? This is X and exit, this ending transaction ID for the delta detection. This is recompute, whether you are looking to do a full refresh or we are looking to do an incremental refresh, right? Then we are looking to have a finished XID list, which has been more like a common separated list for the process XID, like what all record is being already processed. And then we are having the cascade XID, current cascade refresh transaction, like okay, what all, if there are like multiple MVs are there, how those are being structured, and how those, and the last cascade XID, right, previous cascade ID, and all those dependencies tracking. So this way it will be know which has to go and which one has to go and refresh it based on the when you will be looking to go and perform the refresh. Other section is more around the decision point. Hey, whether we are looking to go and recompile it, whether you will be looking to perform the full recompile, or we are looking to perform the incremental refresh. So in the full refresh, what we're going to happen is we will be going to have if the full refresh is true, it's going to have a 5-step. One is to create the temporary table with the refresh data. Other is redirect view or to the temp table. So this way, and then you will be, your query will remain consistent, and then it will be, what we'll be doing is it will be drop your old production table and then rename the temp table which is created earlier to the production table, and then it creates the finalized, like it will point your view again. So this way what will happen is you will be not it will be performing the swapping of the data. At the same time, it will be not having any impact on your production system. So think of like you end up creating this temporary table, and this will execute any new entries against all these three tables. Just end up creating this temporary table, and once it's done, it will be going and pointing to the new table. If you see here, create or replace view, whatever the view name is, select a start from this from this temp view which has created in the step first. The second is it will be going and dropping that old view for you. So this is a temp, this is the old one, and thereafter what it will be doing is it performing the rename of the temp to old and new, and there the step 5, it will be going and creating or replacing that view and deleting your old one. So why this approach? So again, as I said, like zero downtime. Now you will be going and you'll be constantly using the old old MV for you to go and get your data, and while the new data is being processed. Other is the atomic swap, so more like redirecting that query instantly. So this way there is no issues in terms of consistency. And then roll back. If something fail, you can always able to go and have your old data available, right? The section flow is like incremental refresh, right? What it will be looking to do is deleting all the existing table and then insert only the changes from the base table, right? So this is more like, hey, delete the old materialized view, and then you will be able to go and use this you will be using and bringing the data from the source. So this is more like an incremental refresh. So what will happen, it will be delete existing row, only insert the changes the data based on the XID and everything as such, and that much faster as compared to Materialized. We'll be looking to do a full refresh and that still lock the table during the operation. So that is there with the incremental. So these are the way you can able to go and perform the full refresh. This is where you can able to go and perform the incremental refresh. Hopefully this give you an idea how this was how internal working of the Materialized view happened. And other thing around the Materialized view which I have observed is even if you have created a Materialized view, and let's say by default you by mistakenly you run the query against the main table, if it able to find that Materialized view is available, and if you have a table created, if you're still running your query against the base table, it point you to the Materialized view. Also, I have observed many times based on I believe it's based on how the execution plan gets generated under the hood. Sometime in the second use case which I have just explained, if the Materialized view is created, sometimes it's point to if you're running a query against the base table, sometimes it's point to the base table, sometimes it's not able to point to the base table. But again, if you're using the Materialized view, it always point you to the Materialized view. But in case of if you're running a query against the base table by mistakenly, sometimes it's point you to the Materialized view, sometimes it do not. I believe based on if the query is already cached and everything as such, the execution plan decide where it has to go. Hopefully you got an idea. And I said I have end up creating multiple Materialized view, joining all the data together, and then now as the next step I will be going and working on the next step, where I will be going to have connecting this Materialized view via MCP server, Bedrock, Quick Suite, etc. And we'll see the output. So we are very near to our demo, where we'll be looking to go and use these different servers and to go and perform some more interesting able to get insight from our architecture. So if you like the video, please do subscribe, and if you have any very specific questions around the Materialized view, do put on a chat, or please do put on a comment, and I will try to answer those of my best knowledge. So thank you very much, and see you in the next video. Take care.